I'm borrowing from William Shakespeare. I'm sure he wouldn't object. Now, as I told you, increasing carbon dioxide concentrations are having a measured impact on the mean average temperature of the planet. And if you look at the highest number up here, 2000, roughly 2000, I'm sorry, about 1998, that was the biggest El Nino we've ever experienced. But without question, there is no argument about the fact that we are increasing the mean average temperature of the planet over a very short period of time. A time so short that ecosystems, even we, cannot really adapt to that increasing temperature. And here's some examples of temperature increases. And I think you can see that, again, anyone who argues that, you know, global warming is a hoax, well, they're a hoax. Now, what is global warming doing to our planet? This is the purple is the Arctic ice cap, and that was 1979 when we first began to do the satellite imagery. And here we go, 2008. You can see the difference. Heat goes to cold. It's just a physical fact. And the Arctic is warming up faster than any other part of the planet because it's starting from such a low base. But it's also a very sort of not a very deep atmosphere, and the carbon dioxide concentrations up there are significant. But the sun shines 24/7 during the summer months, so you get a combination of more solar radiation but more entrapped heat. Surrounding the Arctic Circle, of course, is permafrost and tundra, which have hundreds of billions of tons of not just carbon dioxide but also methane trapped over the eons. And as this mud melts, it's going to release the carbon dioxide and the methane. And that's called the positive feedback. If this really takes off, it's Nellie bar the door. So when we're talking about global temperature and what we humans need to sort of be comfortable, it's right in here. It goes back 10,000 years. The record coming from tree ring data and a whole variety of sources of information. But now we're beginning to see the temperature increasing. We're going out of the comfort zone. The carbon dioxide increase began measurements in 1957, and I extrapolated out to almost 2020, and I'm looking at 410 parts per million. Today, it's 393 parts per million. Okay, so we're on the way. And it's assumed by scientists that if we reach a 450 part per million concentration, then we're really going to see a significant increase in the mean average temperature of the planet. And there's no turning back from that point. Here are some of the increases in the atmospheric concentration over the years. And you can see that the numbers are going up. And why? Well, we have US, India, China, Brazil, Japan, Indonesia, all increasing our standard of living, our gross national product, driven by the use of fossil fuels. In America, we have 250 million cars. I guess 249 million are basically gasoline and diesel driven. And most of those cars are right here in the district. Sources of carbon dioxide from power plants. I'm looking at the 15 largest CO2 emitting states, and you can see down here at this level here, 2.5 billion tons of carbon dioxide coming from the power plants from just these states. That's about 66% of the total carbon dioxide from electric generation stations in the United States. So if we do try to sort of fix the problem, we're kind of looking at not 300 million people that we have to change our lifestyles. We're looking at huge stationary sources like power plants, automobiles, and increasing costs of energy may cause some of these power plants to shut down or shift to another variety of making electricity. Those plants are, again, sources of carbon dioxide. And this largest blue dot here would be about 1.8 million metric tons of carbon dioxide. So you see the huge concentration of power plants, and it's because there's a huge concentration of coal right here. And some of these power plants go back to the 1960s. So there we have now the target for trapping the carbon dioxide and trying to put it somewhere. Let's see where we're going to try to put it. These dark gray areas are where the geologists think are the most opportune areas for carbon sequestration. Well, now we've got all the power plants in this area here, and we somehow have to get pipes going to these areas to take the carbon dioxide and bury it. This is the oil and hazardous materials pipeline system in America. Now, you can see here, here's where a lot of the power plants are, okay? Not a lot of oil. A lot of oil here, but not many power plants. There, natural gas and oil pipelines. It is said that if we tried to capture all the carbon dioxide from all the power plants in America and put it into pipes and bury it in the ground, we would have to duplicate our natural gas pipeline system. Can you imagine how much steel that's going to require? How much money? How many people are going to say, not my backyard, I don't want that pipe going through my neighborhood, what if it breaks? So, got a problem there too. This is the existing CO2 pipeline system in America today. These are carrying from here down, or I'm sorry, from here up, carbon dioxide from refineries to existing natural gas and oil deposits to augment the pressure and push up more oil and gas. So it's, let's say that we are already capturing and sequestering carbon dioxide, but I probably put out more carbon dioxide than we've sequestered. The Supreme Court says that EPA has the right to regulate carbon dioxide. This is a whole new ballgame now. And the Congress is going to look at legislation driven by this because EPA is on the move to regulate carbon dioxide regardless of what Congress does. Congress is going to say, well, we'll just preempt EPA. But the Supreme Court in 2006 got the ball rolling and said, carbon dioxide is a pollutant. EPA has a responsibility to regulate that pollutant, carbon dioxide. Now I want to bring in the other 800-pound gorilla, and that is the availability of world oil in the out years. And I think this graph tells a lot, but the price at the pump tells us more, doesn't it?